Welcome to O Teachings. Today we'll be talking about current electricity. Current electricity is just talking about how current is flowing through a conductor. Okay, so let me talk about this. If we have a conductor like this, okay, have a conductor like this, and we have the battery here containing V, which is the potential difference, and we have the resistor, and this is the positive terminal and this is the negative terminal. So current flow in a conductor always flows from the positive terminal to the negative terminal. We call it I, and I is standing for current. So in a conductor like this, the current always flows from the positive terminal to the negative terminal. In this conductor, we have three basic things we are looking at. The first one is the voltage or the potential difference, or what we call electric potential. The voltage is the flow of current or flow of charge from one end to another. The charge flows from the higher terminal to the lower terminal, from the positive terminal to the negative terminal. It always flows from high voltage to low voltage. So it is always measured in volts or coulomb per second. While resistance is the ratio of potential difference and current flowing in the battery or the conductor, which have its units to be ohms. Electric current is the amount of current flowing in a circuit, which is always measured in ampere. Another thing we are going to talk about today is what we call electric power. Electric power is the product of voltage and current, or product of potential difference and current. It is always measured in watts. Okay, the most important thing we are going to talk about today, which I'm going to start listening attentively and get your books down. The first thing is, if you have a conductor this way, there is what we call Ohm's law. Ohm's law. Ohm's law is states Ohm's law states that the potential difference in a conductor is directly proportional. Potential difference in a battery is directly proportional to the current flowing in the conductor, provided that temperature and other quantities are kept constant. So whenever there is a proportionality sign, there is always a proportionality constant. So when we say change this proportionality sign to proportionality constant, we have V equal to RR, IR. Let me call it equation what? 1. That means if I decide to make current the subject by dividing both sides by R, I'll be having IR divided by R will cancel R. I will be equal to V all over R. Let me call it equation what? 2. That means the formula of calculating current, as I defined earlier, is the ratio of the potential difference and the resistance of the conductor. So in equation 1, by dividing both sides by I, since we have V equal to IR, if we divide both sides by I, we now have that R is equal to V all over I. Let me call it equation what? 3. That means resistance is the ratio of potential difference and current. Then electric power, electric power P, electric power P is the rate of flow of energy in a conductor, and it's given as potential difference, product of potential difference and current. Let me call it equation 4, where P is electric power, V is potential difference or electric potential, and I is current, measured in watts. Electric power is always measured in watts. We have watts, we have kilowatts. depending on what you are doing calculation on. Okay, in this, by substituting equation 1 and 2 into equation 4. Okay, equation 4 is P equal to VI at V equal to IR in equation 1. By substituting the value of V to IR, we have that P is equal to IR multiplied by I. Okay, we now have that this will be equal to I times I will give me I squared R. That means another formula of calculating electric power is the square of the current multiplied by the resistance. If we consider this statement, electric power to be equal to V times I, and we consider equation 2 to be I equal to V all over R. By substituting the value of I to the V all over R, we have that electric power is V multiplied by V all over R. So we are having V times V, which will give us V squared all over R. Okay, previously I was telling you that power P, electrical power P, is the rate of energy flowing in this conductor with time. So let me call this equation. Okay, here let me call it equation 5. Let me call here equation 6 so that it will be clearly defined. Let me call here equation 7.
Bishop.
Okay, if we decide to cross multiply, we have that energy is equal to power multiplied by time. Let me call it equation 8. Okay, from equation 8, we have that energy is equal to power multiplied by time. So, if we have power to be equal to potential difference multiplied by current, and we decide to substitute the value of the power with in equation 8, we have that P is equal to replacing P with VI, we have VI multiplied by T. Okay, so we now have that energy is equal to VIT. Let me call it equation 9. Okay, in current, there is what we call charge. In current, there is what we call charge. And charge have a sign of Q. Charge is the product of current times time. Let me call this equation 8, not 10. Charge is the product of current times time. Okay, if we decide to make current the subject by dividing both sides by time, we have that electric current is equal to charge all over time. Let me call it equation what? 11. By substituting equation 10 into equation 9, if equation 9 if equation 9 is E equal to VIT, if you look at this particular place, you discover that something is happening here. IT is represented with Q. So I can comfortably change this IT here to charge, which is Q. This makes making Q equal to IT. Changing it here, we have that E is equal to Q multiplied by V. Let me call it equation 12. Okay? I have so many parameters to derive to get series of equations, but this is a good place to stop. With these formulas, we are going to use it to solve series of questions in current electricity.